Hi everyone, welcome back. I'm going to give this video another shot. I've erased some of it because I got like 17 minutes into it and the program decided it was not going to work anymore. So I erased some, we're going to start again. So evaluating algebraic expressions, we're in Module 3, Topic 1, Lesson 2. We're in Activity 4, which is on page 366. To evaluate an algebraic expression means to determine the value of the expression for a given value of each variable. I want you to highlight that, and then we're going to talk about what that means. It says when you evaluate an algebraic expression, you substitute the given values for the variables and then determine the value of the expression. So basically, you're just going to take whatever the variable is equal to. Here it says x equals 10, and we're going to substitute 10 where we see the x. So for example, in this case, we have 3x minus 4. So that means 3 times x, so therefore it means 3 times 10. Now I want you to write up here that there's other words besides substitute. So you'll hear substitute, but then you'll also hear replace. You might hear replace the variable, replace the 10 for the variable, or you might hear plug in the value for the variable, and then solve. So we're going to determine the value of the expression. So we're going to figure out how much is this worth for a given value of each variable. That means identifying what 10 is worth, or x is worth. So here it's worth 10. Okay, let me zoom in on this one. And remember our order of operations. We're going to do parentheses, exponents, multiplication or division, addition or subtraction. And those are in order from left to right. Why is it so glary? Let's see what I can do to fix that. I'm going to pause for a moment. Okay, so I just went over in marker. That makes it easier to see. I think I might want to work in marker here on this page. We've already done the other side anyway. Quick review of that. We talked about the parts of an expression being called terms. The terms are separated by the addition and the subtraction sign. 3x is one term, 4y is one term, minus 7 is one term. The number in front of the variable is called the coefficient. Okay, so our directions say write a sentence to describe the meaning of each algebraic expression, then evaluate the algebraic expression for the given value. So basically, what does this say? Well, this says 3x minus 4, which just means 3 times the value of x minus 4. Another way to say it, we could say 4 subtracted from 3 times x. You could say it like that as well. So then when we substitute or plug in the 10 for the x, we do 3, and that's my kitty making that noise. 3, put the 10 in where the x was. We substitute it in. Here was the x. We have the 10 there, minus 4. Now we just follow our order of operations. So we have 3 times 10, which is 30, and 30 minus 4. So we get 26 for this answer. Okay, over here for letter B, 10 minus z when z equals 8. Okay, so that'll be 10 minus 8. And when we do 10 minus 8, we get 2. I forgot to write out the sentence, which is fine. We'll get it right here. So this says 10 minus z, you could write it as simple as that. You could say z subtracted from 10. Oh, that's a terrible word, from. We'll pretend it's beautiful. 10 minus z, or z subtracted from 10. That's a z and not a 2. Okay. 5 minus y divided by 4 for y equals 2. And I'm going to write it just like that. 5 minus y divided by, no, we want words, divided by 4. You might see it as the quotient. This is probably the hardest way that you would see it. The quotient of y divided by 4 subtracted from 5. I'll squeeze that in there. Okay, and then we have 5 minus y is 2, so we have 2 over 4. So 5 minus 2/4. So 2/4 reduces to 1/2, and 5 minus 1/2 is going to give us 4 1/2. Okay, moving over here. So we have 5 times the quantity of a plus 1. So 5 times the quantity, remember that indicates the parentheses, of a plus 1. There we go. For a equals 20. So 5, and where there was the a, we're going to put a 20. Now, if a appeared here more than once, we would put 20 in every time we saw a. Okay, order of operations says we do what's in parentheses first. So then we end up with 5 times 21. And then when we multiply those, we get 105. So that's our final answer there. That's our final answer over here. Okay, b squared divided by 4. And that's how I'm going to write it. B squared divided by 4. For b equals 8, so we'll have 8 squared divided by 4. I'm going to have to write this one across because I'm running out of room. They don't give us much room to write here. So 8 squared is 64 divided by 4, and that gives us 16. Okay, next, 11 minus s cubed. So I'll change this one a little bit. I'll say s cubed subtracted from 11. And then s equals 2, so 11 minus 2 cubed. Order of exponents says to do the power first. So 2 cubed is 2 times 2 times 2. So 2 times 2 is 4, and 4 times 2 gives us 8. So then we have 11 minus 8, and then we have the value of 3. Okay, moving right along. So now it says complete each table. So for this, they're going to give us the same expression and then 3 different values that they want us to use for it. I'm going to do that on another piece of paper just so we have more space. So 3h minus 2 is the equation they're giving us. So 3h minus 2, and the first value for h is h equals 2. So it says h equals 2 is the first one. So 3, substitute the 2 in for the h. Order of operations says multiplication comes before subtraction. So 3 times 2 is 6, minus 2, we have a value of 4. Okay, so now we have 7/3. So h equals 7/3 now. So we still have 3 times h, so 3 times 7/3 minus 2. Okay, I'm going to put this over a 1. Now, a lot of you can probably look at the diagonals here and see that we see a 3 over 3, and that cancels out because it's literally 3 over 3, 3 divided by 3, we get a value of 1. If you don't see that or understand that, it's okay. You can multiply straight across the numerator and the denominator. If you did so, you would get 21 in the numerator and 3 in the denominator. 3 times 7, 21. 1 times 3 is 3, minus 2. 21 divided by 3 is 7. Up here, if you would have done that cross-canceling, you would have a 1 and a 1, and then you would have multiplied across. 1 times 7 is 7, 1 times 1 is 1. You would have still gotten the 7 minus 2, and for this we get 5. Okay, so we're going to fill a 5 in here, and now we have 5.1. So h equals 5.1. So 3 times 5.1 minus 2. 3 times 5.1, if you're not sure, I'm going to do it off to the side here somewhere. So 5.1 times 3. 3 times 1 is 3. 3 times 5 is 15. We have a number in the tenths place, no decimal place, so our final answer has a tenths place. You can also think of it as one number after the decimal, no numbers after the decimal, a total of one number after the decimal. So this right here replaces with 15 and 3/10 minus 2, in which we would then get 13 and 3/10 as our final answer. Okay, so the next one says 2z divided by 3. That's kind of hard to see. Hopefully you have your book right there with you. 2z divided by 3 plus 1. Okay, let's go to a different color. 2z divided by 3. Is that what that said? It did indeed. Plus 1. Okay, and then they have when z equals, they're giving us z equals 1, z equals 2, and z equals 3. So we're going to do all of those. Okay, so let's substitute the 1 in first. So 2 times 1 divided by 3 plus 1 whole. 2 times 1 is 2. There's nothing to multiply the 3 times, so we have 2/3 plus 1. So right away you're probably thinking that's 1 2/3, which is correct and completely acceptable. Some people may have done this. They may have said 2/3 plus 3/3 and gotten 5/3 as an answer, which 1 2/3 is the equivalent of 5/3, so either is correct. So on the table then, we could have 1 2/3 or 5/3 as acceptable responses. Okay, next z equals 2. So we have 2 times z plus 1, and the 2z is divided by 3. 2z divided by 3 plus 1. Substituting in a 2, so we have 2 times 2, that's divided by 3 plus 1. 2 times 2 is 4. So we have 4/3 plus, I'm just going to change this right now to thirds, 3/3. And when I add that together, I get 7/3. We can leave it like that, or we can turn it to a mixed number I can get 2 whole groups of 3 out of 7. That would give me 6. 2 times 3 is 6. 7 minus 6 means I would have 1 left over out of the 3. So 7/3 or 2 1/3 are your answers there. I'm just going to use this. 7/3 or 2 1/3. And it doesn't matter which order you write that in. Okay, lastly is 5. So we have 2 times z divided by 3 plus 1, when z, trying to make my z not look like my 2, when z equals 5. So 2 times 5, that divided by 3 plus 1. So 2 times 5 is 10 over 3 plus, I'm going to change the 1 to 3/3. 10/3 plus 3/3 is 13/3. We can get 4 whole groups of 3 out of 13. That would give us 12, and there would be 1 left over. So 13/3 or 4 1/3. So 13/3 or 4 1/3. Okay, and I think I'm going to do a separate video for page 367.